Good morning, good afternoon, or good evening, regardless where you are in the world. Thank you so much for attending this session today. This is, I believe, the last session in this channel today. So I get to close out this channel at the past Virtual Summit 2020. This is modern storage technologies for data professionals. And guess what we're going to be talking about today? Storage. My name is Argenis Fernandez, and I am a principal architect with Pure Storage. We're definitely going to be talking about a variety of different technologies and a variety of different characteristics of different storage devices that exist out there. Kind of keep in mind what is good for what, right? This is really what I want to get out of this. So you guys understand that there are multiple choices when it comes to storage, some better for the use case than others, right? I am not trying to sway you in any way, shape, or form into you should be using a particular way of doing storage for your SQL Server enterprises. I really want to just inform you on what's available out there and the different characteristics of the different devices that exist out there and what can you do with them. You know, besides the performance aspect of things, which is clearly super important, we will also try to focus a little bit on, you know, how do we exploit that power behind those storage devices for multiple purposes. Anyway, so we are going to talk a little bit about the things that PAS has to offer in this slide. If you're not familiar with all the resources available in PAS.org, I will highly recommend that you log on and check those out. There are tons of recordings from previous summits freely available in there. There's tons of recordings from other events that have taken place, tons of content that is at the ready for you to peruse and enjoy. So log on to PAS.org today. Please consider becoming a PAS Pro member. So that way you can also get additional training and additional networking opportunities. Join your local user group if you have one nearby. There are tons of them around the world, and they schedule typically monthly meetings, you know, depending on the geo. SQL Saturdays, free one-day local events, obviously taking place virtually these days. Same with the user groups. But there are definitely opportunities for learning that way. So there's also, you know, events like PAS Marathon, which are like webinars, and the virtual groups, of course, is in different flavors of the virtual groups. You have the performance, the cloud, the high availability, et cetera, et cetera. So there's tons of different virtual groups out there. Make sure you check those out. And if you feel like it, volunteer. That's a great way to get involved with our community. So thank you. Go ahead and move forward here. Oops. This is super important. We need your evaluation. Us speakers, we do this for you, but we need your feedback to understand whether we're doing a good job or not. And so we would like the things that worked out well highlighted, as well as the thing that didn't work out so well highlighted. So that way we can actually take that feedback and get better. It's the only way for us to get better. So please consider submitting your session evaluation today. You have a deadline of Friday of next week at 5 p.m. Eastern to submit your evaluation so they can enter raffles for prizes there. All right, so like I said before, my name is Argenis Fernandez. I am a principal architect with Pure Storage. You have my contact information there. I am a Microsoft Data Platform MVP, formerly known as SQL Server MVP. There's a little gap in between the many years that I've been an MVP because I did go to work for Microsoft and the SQL Server engineering team, also known as the Tiger team out there, where I was a principal PM. I am also a VMware vExpert. I've been for several years as well. And I'm also a Microsoft Certified Master. If you haven't heard of that certification, it's now deceased certification. It's been phased out by Microsoft. It's been discontinued, but it was the highest technical certification that Microsoft once had for SQL Server technologies. So this presentation today is actually part of the big data clusters learning pathway. And so you can see there on the slide, there are tons of different presentations that are kind of arranged in a learning pathway. So you can choose how to learn more about big data clusters in your own terms. So we're definitely going to be talking about storage for big data clusters. It's going to be a part of this presentation. But The key here, this slide, is understanding all the different presentations that are available out there. If you missed them for whatever reason, you can definitely go back and watch the recordings for them. If you don't even know what big data clusters are, you definitely want to learn more about them. It's a new architecture, a new topology, a new way of deploying SQL Server for your enterprises. And so we're definitely going to be talking a little bit more about that during our presentation today. But I just wanted to make sure that you understood that this presentation is part of that pathway. And we're kind of like at the bottom of the cake, and we're only going to be talking so much about big data clusters, but it's still interesting that you can connect the dots on, if you're deploying a big data clusters, what storage technologies can help me for that. So the agenda today is going to be pretty straightforward, right? Well, I do want us to revisit the storage basics, and that's because I can't just make the flat out assumption that everyone on the line today understands the storage basics. Understanding those basics are important so that we can actually understand the benefits and the cons of every technology that we're going to discuss today, right? And a lot of these things that I'm going to mention here today are going to be a little esoteric, meaning you had no idea that they existed. That's totally okay. And you have no idea how they apply to you today in your daily jobs. That's also totally okay. But what I want you guys to really understand is, when I look at a storage solution, what am I looking for in there? How is that going to make my life easier? And if it's going to make my life easier, and what else can I do with it? So that's really why we want to talk about all these things. So storage basics, definitely going to be talking about that. We're talking about PMEM, persistent memory. We're going to be talking about NVMe and PCIe. We're going to be talking about SmartNICs and Project Monterey from VMware. And we're going to be talking about, obviously, classic all-flash arrays. We're going to be talking about object storage, which is some of the newer technologies that's only been around for so long. We will definitely talk about the cloud. It's not going to be the main focus of this presentation, though, but we will definitely talk about cloud a little bit. Depending on time, we'll see how much we can extend on that. And then we'll talk about big data clusters at the very end of it, okay? So let's get going, because obviously this is a ton of things to go over. All right, so let's revisit the storage basics quickly here. Not going to show you any graphics, not going to show you anything fancy here. I just want you to understand four basic concepts, okay? Storage has performance characteristics. The performance metrics that you typically use for storage are latency, IOPS, throughput, and queuing. Okay, so those are typically the four metrics that you look at. Why is each and every single one of them important? It's super critical to understand. Latency means how long did it take me for me to place a request for an IO to be served by my storage device back and forth. So a SQL Server database, for example, imagine a table wants to write something, you want to insert something into that table. You're going to be generating some transaction log records for that operation, regardless of whether you have a heap, a clustered index, or a non-clustered index. Those operations are going to translate into log records, right? Following the write-ahead logging protocol that SQL Server has. And then eventually those records will be reflected into your data files, right? Through checkpoint and/or lazy writer. Key there is that as you write to the transaction log, those records have to be transformed into IO, right? They have to be IOs placed against your storage device for your device to actually persist those transaction log records. And they do have to be persisted all the way through. You cannot just write a transaction log and cache it somewhere in that volatile area of memory. That's forbidden, completely forbidden by the SQL Server storage engine. So important to understand is, what latency do you incur when you write into the transaction log? That is fundamental, right? For performance of SQL Server, latency is a big deal. And this applies to every single database. As you make modifications to that database, the faster your storage device will be, the better off your performance will be, naturally. But not all storage works the same. So maybe some can give you better latency, but they're missing on other areas of the equation. And the equation is high availability. What things can I do with that storage? How do I back it up? How do I do things? And so that's just on the latency aspect of things. IOPS is the other thing that everyone talks about when looking at performance metrics. There is something fundamental that you need to understand. When you issue a request for an IO, that IO doesn't have to be always of the same size. It can be a small IO. It can be maybe a 512 byte IO, tiny IO, or it can be an 8 megabyte IO. Huge difference, right? Tons and tons and tons more data on an 8 megabyte IO. SQL Server doesn't have a fixed block size, a fixed IO request size. It never does, right? Depending on the operations that it's performing, you're going to see a given pattern for those for IO operations. If you have a very transactional workload, for example, you're going to be hitting a lot of transaction log flushes because you have a lot of modifications going against that, against your database. And if you had more reads than writes, you're going to see more throughput than transactions going into those writes. You can start picturing that in your head, right? But the IOPS measurement has to come with a block size attached to it. Because all the IOPS means IOs per second. How do you measure IOs per second if the IOs can be of different sizes? That's a fundamental problem, right? The IOPS on a backup operation will be less, but there will be more throughput because the aggregate amount of data that we're sending at that time when we're making a backup is very different than the amount of throughput that we're generating when we're just writing transaction log records, typically. Right, so that is the consideration for latency, right? Round trip time. IOPS, how many IOs per second I am actually performing at a given IO request or IO block size. And then throughput, which is the aggregate of all the IO requests that I'm sending at any given time. How much bandwidth am I actually sending down to my storage device or reading from my storage device or writing to my storage device? Just, obviously, when you're writing something, you're sending the data along with it. When you're reading something, you're retrieving the data from the device, right? This is naturally how storage devices work. But those are the basic concepts. And the fourth concept is queuing. How many operations do I have pending against my device? Queuing is not something that happens just exclusively on storage devices. Queuing happens at the file system level or at the volume level, which is a construct that happens at your operating system level, not at your storage device level. So you may have a pending queue of operations against that particular volume in Windows or Linux. But even on top of that, SQL Server has a queue of operations that it has issued, right? SQL Server doesn't do synchronous IO, meaning it doesn't actually issue an IO and just sit and wait for it to complete. Right? Whenever possible, and this is 99.99999% of the time, SQL Server will just issue an asynchronous IO from the application itself, and it won't wait for that IO to be finished. It will check on it repeatedly to see if there's any response coming from those IOs that it has requested, but it won't sit and wait for it. If it does sit and wait for it, you have a bad performance problem, and you have bigger issues that you need to go fix. So if you're seeing synchronous IO warnings on your error log, you need to go fix that now, because that's obviously a very big issue for performance. Remember, your CPUs, your memory, everything in your system moves way faster than the storage device that you use, regardless of what storage device you use. So it's super important to understand that SQL Server will take advantage of that additional time that it has to complete storage operations before it actually it goes and checks on what happened with that IO that it placed against a storage device. Storage devices, in the big scheme of things, are slow, and that's something fundamental to understand. So let's talk about persistent memory. This is some of the technology that hasn't really been around forever. It sort of has, and it sort of hasn't, because guess what? The original memory that computers used was actually persistent. Before DRAM, or dynamic RAM, what your servers use today for RAM, came into the market, persistent memory was a thing, which is shocking. It's just that DRAM was actually cheaper than the memory that was used back then. It was an interweaved memory kind of thing. Made out of, it's a magnetic core kind of memory. That memory is obviously ancient history. No one uses that anymore. With the advent of dynamic RAM, like the RAM that your PCs or your laptops use today, that memory enabled a new generation of processors and a new generation of workloads, right, at a much cheaper cost than the other ancient technology. But as time passed by, people realized that some workloads needed the lowest latency possible for IO operations. And if you start thinking about how a computer works, you have a CPU complex and you have a memory complex connected through some technology. and some connectivity to the memory banks are faster than others, regardless. Some CPUs handle memory access better than other CPUs. But the gist of it is, if you can have your I/O be as close as the speed of memory as possible, then you're getting the best latency possible. So persistent memory is a great, great, great technology. And so in the last few years, there have been some significant advances in persistent memory, where you have things like Intel's Optane DC, which is what you can see right here on this slide. And that is actually not based on your traditional DRAM technology, right, which is still sort of expensive and not persistent at all, right? So the dynamic RAM on your computers today is volatile. So when you reboot your server, that whatever data you wrote to that DRAM, it's effectively gone. Not these, right? Persistent memory is effectively what the name says, persistent. So whenever you write to these things, that information will be there, and it will remain there throughout the lifetime of the system. It can withstand reboots. It can withstand power losses. Okay, so it's super cool tech, and fundamentally can change the way your workload behaves, because you can write to these as if it were a disk. Right? You can have Windows recognize these, or Linux recognize these as disks, and you can just put anything on top of them, including your database files, including your transaction log files. There's a problem with that, though, isn't there? This is not these devices don't have redundancy per se. Meaning, if you write to them, if you lose the device, you're toast. Your data is gone. So that's why they don't fix every single scenario. They don't fix every single problem. And they can actually cause problems when you do run into a situation where you cannot access the box where you had that data for whatever reason. Right? So it's important to understand that persistent memory gives you low latency. The technology to replicate persistent memory as fast as possible, so that you don't actually incur into low availability situations, meaning you lost your box, but you still have it replicated somewhere else, so you can go read from that other box. Those technologies are continuously being developed. Some of them exist out there, but neither Windows nor SQL Server have fully embraced these kinds of technologies yet. Linux has, sort of, but not SQL Server running on top of Linux. So I can picture a very near future where we're going to see some technologies that are going to embrace replication of PMEM over RDMA, so very high-speed network links in between servers. So that way, if you write to a persistent memory device, you can actually have that data replicated to another persistent memory device. In case of a failure, you just go read the data from that other machine. As you can imagine, accessing a persistent memory as disk is actually not as fast as you would think, because you're still going through the operating system stack for I/O. And that's not the most optimal way of accessing something that should be treated like memory, right? And so SQL Server 2019 actually came out with a bunch of features to embrace persistent memory, right? Like hybrid buffer pool and enlightenment and Linux, right? I'm not going to talk about those here today, but understand that Microsoft is making investments in supporting this kind of technology and embracing this kind of technology so that it can be used more effectively. One of the things that persistent memory enables, and enables fairly well, is hyper-converged infrastructures. And I want to talk about these very briefly because I want to make sure that everyone understands. When they hear hyper-converged, what is it that we're talking about? Hyper-converged basically means all of my servers have some storage, some faster than others, right? So some layer of storage is faster than the other layer of storage. So there are tiers of storage. There is a hypervisor layer that abstracts all the hardware running underneath the hood, and your VMs are running on top of that. So there are some considerations for hyper-converged infrastructures. If you write something to, even if you write it to the fastest tier of that within that machine, you have to replicate that data to at least one other machine in your hyper-converged cluster so that you actually have redundancy of the data. So that means that every write has to wait until that it gets replicated somewhere else before you actually move on. That's kind of how it works. So you can expect your data to always be available within the cluster. And so there are replication factors, Okay, so you can replicate to only 2 nodes, you can replicate to 3 nodes. 3 nodes is what typically you would be doing out there, right? Because you want n plus 1, you want kind of a that copy plus another copy in case you have 2 failures at any given point in time, because otherwise you lose the data. That's a big deal, right? And this is where it becomes very relevant to understand how many copies you have of your data in a hyperconverged infrastructure. And so hyperconverged has multiple vendors out there that sell that kind of model. The more renowned ones are Nutanix. Microsoft has something called Azure Stack HCI. Cisco has something called HyperFlex. There's a bunch of different offerings out there from different vendors for hyperconverged infrastructure. But the way to go with hyperconverged infrastructure is to make sure that the fastest tier for storage is actually persistent memory, because otherwise you're going to be running to something way slower, and you're going to have to replicate it across the multiple nodes, and you're going to run into performance issues. So just keep that in mind, because that's the best way to go if you're looking at hyperconverged storage designs. This is the other way of doing storage on servers today. You can use your PCIe bus to attach storage to your machine. It's a great way of doing it. So by the way, before we move on, the latency on persistent memory can actually be measured in nanoseconds. Okay, depending on the persistent memory that you use, it can be measured in nanoseconds. So let's think about the scale: seconds, milliseconds, microseconds, nanoseconds. Okay, each one is divided by 1,000. So this thing is actually fairly fast. It can move at the same or near the same speed as your memory in your computers or your servers. Okay, so there are others like persistent memory from Intel. It's actually on the low microseconds of latency, right? Very low microseconds of latency, potentially hundreds of nanoseconds of latency. That's from what I have seen. The numbers may be better these days. So keep that in mind. Latency matters, right? How fast am I writing to these things? What orders of magnitudes am I tracking for these devices? That kind of matters. So for PCIe devices, though, think about the graphics cards that you put on your computers, right? So your NVIDIA cards or your AMD Radeon cards. Those go attached to a PCIe bus, right? So those are very high bandwidth links that within your connected to your CPU. The PCIe lanes, how many, and the speed of them, and the version of the protocol for PCIe matters. For example, the newer devices these days are supporting PCIe 4.0, just a fairly good spec. PCIe 5.0, it's actually in development right now. And not all Intel processors support PCIe 4.0 though. The newer AMD processors do support PCIe 4.0. Intel is catching up on that regard, if I understand things correctly. Regardless, the way that these devices work is basically you put them on the same slot where you would otherwise put a graphics card on your PC. On a server, you just plug in this storage, right? And this storage can be powered by several different mediums, like what actual medium your data ends up in. That matters. So the Optane medium, it's typically faster than NAND flash, which is the typical medium used on an SSD. Okay, the Optane technology was co-developed between Intel and Micron over several years, over the last 8 years, I believe. And so what they were aiming for, it's extremely low latency mediums that would actually be persistent and wouldn't suffer from the issues that NAND suffers from. NAND being, again, the medium that you would use on SSDs. And so the issue there is, if you have a workload that benefits from lower latency, and you cannot quite require, or you don't quite require PMEM-like performance, but we need the benefits of lower latency, even than that of our traditional NAND-based SSD. These cards are for you, okay? And so they can get you fantastic latency, tens of microseconds of latency. In the latency is in the tenths of microseconds, so it's fairly good. The problem with these cards, again, is they are, by the way, much cheaper per gigabyte than PMEM devices are, much cheaper. But the problem with these cards is that you still have to replicate the data that you put in them, because they don't come with a high availability solution baked in. If your server goes up in flames and you've written data to your card and you haven't replicated that data anywhere else, you're toast. That data is gone. So what customers do when leveraging these kinds of things is use things like availability groups, because that you're actually replicating the data at the SQL Server level. So if you write something, you make sure that you write it somewhere else before you move on. So there's typically an AG in a sync replica for an AG under this particular storage model. That's because the storage is not shared, right? You cannot string a card and plug it in another box without requiring significant downtime and somebody going into the data center, unplugging things and plugging things back in. That seems completely ridiculous, and it is, right? You shouldn't be thinking about it that way. You should be replicating the data at a different level so that you don't have to do that. Right? You don't want to go into that data center. And this is the kind of stuff that is in use in the cloud for ephemeral storage, right? So when they tell you your Azure VMs have ephemeral storage, what is it comprised of? Typically something like this. It may not be this, but something close to it. It may not be Optane, but it may be Flash. Still plenty good, plenty low latency, plenty of throughput available from them, and plenty of IOPS available from them. But it may not be. The problem with those in the cloud is that they're not persistent. So you have to replicate the data that you put in them somehow if you care about that data at all. This is also why they tell you to use the ephemeral storage for things that are volatile, like TempDB. You don't care if your VM all of a sudden gets deallocated and TempDB was sitting on one of those drives. You can just light it up on the ephemeral storage on another VM. It's going to get reconstructed anyway, right? So that's why this technology is important, because it enables you to do to have this technology at the ready for ephemeral workloads. And if you care about the persistence, then you replicate at a different layer. So Mr. Beard's telling me that a relevant question came in. Please go ahead.
Thank you, my friend. So Frank Gill has asked, what is the expected lifetime of PMEM, NVMe, and PCIe?
So those are great questions, Frank. So the lifetime of an Optane device is limited, but it's extremely long. Same as Flash. It is also limited, meaning you can only overwrite so many times before the medium degrades. But the amount of times that you have to write, or the amount of data overall that you have to overwrite, which can be measured in terabytes or petabytes sometimes, is significant. And I'm sorry that my son is hitting my camera here. That's why you see this spots on my face right now. It's kind of funny. It's a great question though. These mediums are not eternal. Your PMEM will degrade over time. How much? It's typically not a problem. Same with these cards. It's typically not a problem, but you still have to keep in mind that they could go bad, right? You also have the problem that you could get a bad batch. Just like you got a bad batch of hard drives in the past, you could get a bad batch of these. That happens, so you have to test them before you put them in production. And it's just a good exercise to do on any storage device that you are about to deploy in your infrastructure. That's a great question. Each device has specs, technical specifications, a sheet that's available on the vendor's website that tells you exactly how long the device is going to last. And you should be guided by those. As you approach hitting those numbers, you can keep track of them, because each device you can query for how many writes you've performed against it. It's basically low-level information about the device. The device will tell you how far from that actual number you are. And that's something you may want to keep an eye on. It's a great question. Anyway, I think I'm done with this slide. So at this point, I think I want to move on, because we're also about halfway in. I think it's already 1 p.m. Here on the Pacific Coast. Anyway, SmartNICs and Project Monterey from VMware. This is fairly new, okay? But the name of this presentation is Modern, so I wanted to talk about Modern, all right? Some of this stuff is not even available for SQL Server yet, but it will be. And a lot of you guys are running SQL Server on top of VMware these days, and you may be wondering, how can I make my workload even better? How can I make my SQL Server even better? How can I extract every single ounce of performance out of my SQL Server VMs on top of VMware? This is one way of doing it. Okay, so the idea is that these cards actually run a version of the hypervisor for bare metal boxes. So they actually belong to an ESXi cluster, even though your box may be bare metal. And in the case of VMware itself, it can actually defer a lot of operations to the card and give you great performance connected to a storage network and handle a lot of the complex operations on the storage side for you. So this is all nascent technology, and it just came out, but I think it's going to be popular, especially for very demanding workloads in the enterprise, right? So there's something to keep an eye on. SmartNICs and Project Monterey from VMware. It was just announced as a follow-up to Project Pacific and Tanzu and all these things from VMware at the last VMworld in 2020. So more to come on that. My friends who work for a company that makes these devices, Pensando, you can see one of the products there. They tell me that they're going to come out with SQL Server specific collateral and things that you can peruse in the near future. So moving on to the most classical ways of deploying storage in enterprises out there today on-prem, all-flash arrays. Full disclosure, I work for the company that makes the one at the very bottom of the list. Okay, these technologies are super useful because not only do they get you great latency, mind you, it's not the same latency that you would get with a PCIe card, right? It's not the same latency that you would get with a PMEM device, right? So PMEM is measured in microsecond, in high nanoseconds to microseconds. PCIe and NVMe is definitely measured in mid-range microseconds, low dozens of microseconds. And then all flash devices these days are actually measured in the 100 to 200 microsecond range, right? Depending. Some of them are better than others at latency overall. But the cool part about all flash arrays, typically you would connect these through a SAN. Okay, there will be some storage network in between your hosts that actually run your SQL Server. So if you're talking bare metal, you would have some connectivity to your arrays, either iSCSI, fiber channel, or potentially NVMe over Fabric. And we'll talk about NVMe over Fabric in just a second. But the idea is you will connect to those devices so it can be shared storage. You can share them across multiple hosts, and all the hosts can send the workload to these devices. You can create your volumes in these devices and present them to your hosts, whether, again, bare metal boxes or hypervisors, or regardless of whether you use Hyper-V or VMware or what have you, you could easily use these. So the fundamental thing to understand is for these guys, they actually have data services. And data services is important for a lot of different things. They have high availability baked in, for example. Typically, you have more than one controller in these things, meaning if one controller dies, the other controller can handle the workload. And so there are some mechanisms for failover at the controller level. They vary among the different vendors. The one on the top is the Dell EMC's Power Store. The one in the middle is a NetApp AFF's A series. And then the one at the bottom is a Pure Storage Flash Array X. So all of these devices have typically 2 or more controllers inside of them. Some of them you can scale out in a cluster. And then the way that they work is you issue IO against them and they reply, and that volume can actually be spread across multiple controllers. You may have to install some software on your machines to handle a multi-controller scenario, a cluster scenario kind of thing, but they just work. You just issue an IO, they reply with the IO, but they can do so much more. And that's the key about the all-flash arrays, right? They give you good performance, but then you can do things like snapshots, clones, replicating data across arrays. And then some of them even offer you the capability of taking data that you write to them and replicate it automatically to the cloud. And so these things are cool, and you want to hear a lot more about the functionality that you can achieve with these things on my other talk that we delivered here at the past summit. That's called Modern HA and DR Topologies. because that we do talk about those things in there at length, regardless of which vendor you use, by the way. That session is sponsored by Pure Storage, but the concepts are generic and apply to all the different vendors. So you definitely want to keep an eye on that. Again, these technologies can be great because, if you're in the low 100 microseconds of latency, you can still deliver good performance, and they can do tons of bandwidth too, right? Tons of throughput. I've seen some of these devices achieve 10, 15 gigabytes per second of throughput, which is basically the same throughput that you could achieve with a bunch of PCIe attached cards, or even persistent memory devices. So you can achieve, depending on your workload, this may be the way to go. If you go with one of these, you typically will deploy, regardless, you won't care too much about the SQL Server topology that you use, because you're free to use whatever you want. On the previous devices that we talked about, you kind of have to replicate it in some way or another, right? You can have a hyper-convergence layer replicate data for you, right? If you're using Nutanix or using Azure Stack HCI, right? No problem. But if you're using one of these devices, or maybe you were using AGs on the previous scenario, if you're using one of these devices, though, you can just create a failover cluster instance, because your storage can be HA and can give you several nines of availability over time. Can you do AGs on top of this? Sure, right? Especially you don't have to get one, you can get more than one. And obviously you can spread your AGs across multiple of these. And so our customers deploy this stuff in several different ways with several different methods, and how the architecture, what it looks like on top, matters very little, right? We just give them recommendations on what to do for every given scenario. But you can do interesting things with snapshots, right? Avoid a size update operation, recover your entire database in just a few seconds, rather than going over entire backups and restore operations and that sort of thing. I talk a lot more about that in the HIDR talk, so please go check that out if you're interested in that part of the discussion. Moving on, object storage. This is also kind of interesting. If you guys remember how things went like, in the cloud, you started seeing this S3 thing pop up in AWS. And everyone was like, oh, that's interesting. It doesn't work like a file system. There are buckets and you just drop objects in them and you do things with those objects. Those objects can be anything, right? They can be an image, they can be a database, it can be a backup, it can be a bunch of things. And you don't really think about it in the same way that you thought about a file system, right? Where an SMB share or an NFS share, you just look at it in a different way, right? It's a different kind of abstraction layer for your data. But it can be extremely useful and extremely powerful, because if you're doing entire data lakes where you have a bunch of files of different sorts that you need for your big data processing, for example, you can have your files, your big data files, sitting on the same storage as your backups, or sitting on the same storage as your images. And that enables a lot of very interesting scenarios and things that you can do that you otherwise will be a little limited, because you had different silos where your data could live. And that's the interesting part about this, right? So if you start thinking, can I use these things for SQL Server specifically? Well, you sort of can, because this object storage devices, and I have 4 of the main players that exist in the market right now. Again, this full disclosure, I work for the one that makes this white one here, right? There's vast data at the very top. There's the Dell EMC Isilon. There's a Pure Storage FlashBlade, and then there's the NetApp storage grid. All of those support S3 on-prem. So now the same concepts that you had for data being sent to the cloud, to a object storage in the cloud, you can do on-prem as well. And these devices can also replicate data between on-prem and the cloud as well. So if you write to your local buckets of storage, or to your object storage locally, and have the devices replicate for you to the cloud. Isn't that interesting? There's even support for S3 from the likes of Idera and Redgate and Quest software, right, for your SQL Server backups. So as you read your SQL Server backups from your storage devices, regardless of where they live, you can actually push those backups into S3 buckets, not just in Amazon, but also on-prem. So that's interesting, because there's a lot of things that you can do that way, right? Like, you can immediately start replicating your backups to the cloud that way, for example. You can still take them at very high bandwidth, very high throughput, and still send the data to the cloud, have the offloading of the replication part of required there have the device handle that for you. So Mr. Beard here is telling me that another question came in, so I'm going to pause here. Beard, go ahead.
Hello, sir. So would you like a technical question or a slightly simpler one?
Throw everything you got at me, man.
Okay, so is there a taxonomy for these hardware acronyms for new people who don't understand what they all are?
Oh my gosh, I'm so sorry, first of all, because you must be lost. I guess must feel like I'm speaking Chinese here. I am, no offense to the Chinese people on the line. There is not a centralized place to learn all of this. Sorry, but you can email me and I can probably find you a bunch of good resources. If there's something I said and you absolutely have no idea what I'm talking about, please ask the question specifically and say, I don't understand what such and such means. Can you please dig into that one? And if time permits, I will definitely dig into it. Deal? What's the next one, Beard?
So the next one, there are a couple on NVMe. So would you recommend a hybrid strategy if you're worried about hardening of NVMe memory?
Would I recommend a hybrid strategy? What does that mean? Like some data sitting on some device outside of the of the box?
That's what I understand. Because we're worried about the hardening of that memory, then
so what
electromagnetic or something, then maybe we could.
Right. So you can only fit so much data in the NVMe devices, in the PCIe, local PCIe NVMe devices. And so the problem becomes if your database is too large, sometimes you're not going to be able to fit it. Or if you have too many databases that have to go into that instance for whatever reason, they may not fit across all the different devices. So what customers do is that they place the log in NVMe, and then they place the data on some device outside, like a storage device or like a storage array. That's a pattern that we're seeing more and more. And they replicate log using whatever mechanism they feel is best. So AGs is the typical one that someone would use right now. We still have tons of customers using mirroring in that scenario though. Log goes on PCIe NVMe, data goes on a storage array connected to the hosts. And so they replicate using they replicate log using the mirroring replication mechanism. It works. You don't have to have everything in the same bucket. That's one way of achieving high availability and a hybrid kind of scenario and you actually get quite potentially the best of both worlds. But there's a big but in there. And that is, if you want to leverage some of the functionality that the devices offer, and we're talking specifically about all-flash arrays, if you want to leverage some of the devices that these all-flash arrays offer, like snapshots and clones, you have to have log and data on the same volumes. Otherwise, you will never be able to guarantee that a snapshot is a good snapshot. That's just the way it works. Unless you orchestrate the snapshot at multiple different layers, quiesce all I/O all together, then take a snapshot on the multiple devices involved through whatever means you can achieve that. And then the aggregate of all of those things across the different storage devices will constitute a good snapshot. So that's something important to understand. If you're in just because of the performance and the capacity, do you want to do hybrid? Yes. If you're in that model because of the data services, no. I would highly recommend that you put that on the same storage device outside of the box if you want to leverage storage device data services. Or even if you want to do things like deferred, synchronous replication of writes offloaded completely from SQL Server, which is possible using all flash arrays and using other storage devices. So hopefully I answered that question. Please follow up with more questions if you feel I haven't explained something well enough. Anyway, to wrap up the discussion on object storage, understand that the things that you can do in the cloud, you can also do on-prem. You can have the same experience. You can have S3 buckets that you just write to and use for whatever you want, including potentially SQL Server backups. And this is also interesting for, drum roll please, big data clusters. Because if you have some of these things speak HDFS, some other things speak S3, and that means that you could potentially use these devices to power the HDFS portion of your big data cluster. And that's exactly the conversation around BDCs, right? That's really what we concentrate on. When it comes to BDC, we'll get to a slide over there. We'll talk a little bit more about that. But let me pause here and mention something that's actually sort of super interesting for me. When I said, and I'm going to go back here, apologies for that. I said NVMe and I said PCIe, but I didn't say what NVMe is. And hopefully I'm answering some of the questions I came in with this. NVMe is actually a protocol, just like SCSI is. Okay, so let me clarify that. SCSI is a thing of the past. It'll slowly die over time, and NVMe will come and replace it as a protocol. Okay, when somebody refers to the medium, they may not necessarily be referring to the same thing. There is no such thing as an NVMe medium. You can have Optane medium or a NAND-based medium, a flash-based medium. Okay, that's important to understand. How you access those devices, though, matters. If the device only speaks SAS, serially attached SCSI, that's going to perform worse than a device that is attached via NVMe, typically. Because if your device is a hard drive and it speaks NVMe, those just came out and are actually kind of weird because they're not as fast. They're just hard drives, but they speak NVMe. So that's sort of weird. You know how you had SCSI hard drives? Same thing. Now you have NVMe hard drives. So, but you also have NVMe Optane drives, and you have NVMe NVMe flash drives as well, NAND-based flash drives, traditional, more SSD-like drives. So NVMe comes to replace SCSI. SCSI. And in that same vein, NVMe over Fabrics comes to replace iSCSI and potentially Fiber Channel. Okay, so that now there are several variants in there, and this is where things get really out of control and how many variants there are. There is something called NVMe over Fabrics that works on top of on top of a converged Ethernet infrastructure. We won't talk about converged Ethernet infrastructure here, but just know it's an Ethernet network, and RDMA-based Ethernet network. Done talking about that. There's also NVMe over Fiber Channel, which is another flavor of NVMe that you can run on top of an existing Fiber Channel network, as long as the device is supported. All the devices involved have to support it. And then, in addition to that, there's NVMe over TCP, which allows you to encapsulate, much like iSCSI does, NVMe packets inside of something that's routable across the internet even. So you could potentially use this anywhere, right? So you could attach some storage that sits on, I don't know, South Africa to a host that's actually sitting in North America. Not that that would be optimal, but I'm just trying to illustrate the point that this is a completely routable, completely transportable protocol, NVMe over TCP is, whereas the other ones are not so flexible. Why do I say all of this? Because I think I do firmly believe that SCSI is dead. And I don't think we will see many SCSI devices in the future. And we will see compatibility with SCSI, but I don't see a SCSI future clearly. For me, this is Argenis expressing his own opinion. And here's the other thing that I will say: Windows doesn't support NVMe over Fabrics yet in any other flavors, and I think they should, because Linux has a huge head start on this, and we are seeing the benefits of NVMe over SCSI on the workloads that customers run against us. Huge improvements in latency, right? Because NVMe is nowhere near as slow as SCSI is when it comes to parallelism and tons of I/O happening at the same time, blah, 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 blah. So NVMe over Fabric is a big thing. And some of the devices that I mentioned here, no object storage, can actually be accessed using NVMe over Fabrics. So that's also interesting, right? That you can connect to these devices through several means, several methods. And you can expose different protocols from these devices. Some of these devices speak NFS at the same time that they speak S3. And you can access the data, even though it's saved through different protocols, you can access them through different protocols. That becomes interesting, right? Because it really abstracts you from how you are actually connect to it. A Linux box can see your SQL Server backups being saved in there, same as your Windows box can see your SQL Server backups saved via SMB to those devices. So that's kind of interesting, right? The evolution of the storage devices that we have seen over time is significant, and the applications to SQL Server scenarios are also very interesting. All right, so let's talk about the cloud. And this is going to take us a little bit of time because we have to, number one, clarify one thing. Storage in the cloud is meant to be abstracted from the actual physical implementation no matter what. That is the premise of the cloud, right? You do not want to understand exactly how your storage is laid out in the cloud, period. They only tell you what the storage can do and how you access it. That's it. Why do they do that? Because they can change the underlying implementation of how they offer that particular offering in the cloud at any time without them telling you how they implemented it. The implementation details are completely abstracted from you. So when they give you a I don't know, some storage that you attach to your VMs, they tell you how exactly what performance characteristics you're going to be able to get out of that storage, and they guarantee you, SLA guarantee you, the performance characteristics of that storage that you bought for that VM. Okay, so the typical example is Azure, right? You can buy, I don't know, I always forget about the different sizes, P3, P30, P60, P90, blah, blah, blah. Some of these can handle more IOPS than others, and you have to also remember what the IOP measurement is in Azure, right? I believe it's 4K. Somebody please correct me if it's not 4K. It's either 4K or 8K, but I'm pretty sure it's 4K. Anyway, every device that you attach to your VMs has limits, and the limits are up front. They tell you can, at the most, do these many IOPS at a given block size, and that means that the larger block size, the less IOPS you will be able to do. Remember the basics. When it comes to throughput, they also have throughput limits. So you could potentially run into the IOPS limit or the throughput limit when it comes to a given storage device in the cloud. And this is where it gets interesting. Sometimes you have to actually stripe storage devices in the cloud. So you use some sort of technology, right? Like Windows has the mechanism of creating dynamic disks, for example. So you can stripe your data across multiple devices and achieve better throughput. But you are also limited on the amount of throughput that you can get out of a single VM. And those limits also have evolved over time, but they're also significantly less than what you can achieve on-prem. The reason why I say that, it's because if you're thinking about putting a data warehouse and SQL Server on a VM in Azure as of the time of this presentation, and if we want to pull more than 5 gigabytes per second of throughput at any given time, that's going to be pretty hard. It's going to be pretty hard because there is no persistent storage that I know of. Please, somebody correct me if I'm wrong. That you can achieve that kind of throughput against a single SQL Server instance, living on a single VM. If you scale out your workload, right, maybe not through SQL Server, but something else, and you want to achieve throughput by scaling out your workload that way, then you can potentially achieve tons and tons of aggregate throughput. But individual throughput may be an issue. Individual IOPS on a single VM is also an issue because VMs are limited also at the VM level on how many IOPS and how much bandwidth you can reach. And this is not just a thing in Azure, by the way. Every single cloud provider has these problems, or these limits, I should say. It's not like on-prem, you're not going to reach those limits either, right? You will, especially if you have poor connectivity between your storage devices and your hosts that are serving your VMs, which is a classical scenario that I encounter out there with customers. I just wanted to make sure that everyone understands that even the cloud is great and gives you this fantastic level of abstraction. It doesn't mean that you can potentially reach the absolute best performance that you can reach in the cloud. It's very difficult to do that, actually. And so what typically customers do is get beefier VMs that have a lot more RAM in the cloud, but that typically becomes with a higher CPU count, so you can handle that RAM, and higher licensing costs because you're using more RAM. Because there is no low CPU, tons of RAM kind of offering. There are few and in between. So you have to be smart. If you want to go to the cloud, and you absolutely should, right? Tons of workloads go to the cloud. Point is, you have to be smart about sizing your VMs, understanding how many CPUs you need, how much memory you need, based on the menu of options available for VM. There's basically a science around this, right? There's calculators and things that tell you should probably go for that VM size versus that VM size, blah, blah, blah. The good news is that if once doesn't work, you don't have to you can dynamically change it, right? You can say, oh, now I want to switch from this VM size to that other VM size, and off it goes. So that is the goodness that you can achieve in the cloud. You can do that on-prem too. It's just, if you don't like what you're getting, you can always try something else. That's all I'm saying. But you need to be smart about the menu of offerings. And I just talked about cloud block storage, right? Meaning the blocks, the volumes that you present to your Windows machines or your Linux boxes, so you can lay out SQL Server databases on top of them. There's also object storage in the cloud, naturally, as I mentioned before. You have your S3 buckets in AWS. You have your ADLS in Azure, your Azure Data Lake storage. You also have blob storage in Azure. You have Ultra SSDs in Azure, and you have the EBS stuff in AWS. I have no idea what the offerings in Google and Oracle look like. I heard that storage in Google is pretty good. I don't have any data to say otherwise or to confirm that. Oracle, I can barely speak Oracle. I can barely mention the name Oracle, but I assume that they have equally good offerings on the storage side as well. The point is, you definitely want to do your homework here. It's super important, right? You just don't want to say, oh, it's the cloud, I can just pick whatever VM and expect performance out of it and expect good responses out of my systems running on it. That is the same mistake that you will be doing that same mistake on-prem than in the cloud. So size your systems is super important. And it doesn't matter whether you're looking exclusively at VMs on the compute side of things, or the storage side of that's going to be attached to a VM. Capacity, what a system can handle versus your actual demands is important. You need to understand what your system demands. You should be looking, if you want the same performance that you're getting on-prem from the cloud, you should be looking at your perf mode counters, right? You should be looking at your latency. You should be looking at your IOPS over time, naturally, and you should be looking at your throughput over time as well. And it's not like you're going to size a system. I'm sorry that I'm going on this little rant, but it's true. A lot of you don't pay attention to these things. Do you even know what your system looks like on a full business cycle? If you're an HR provider, are you seeing the same workload on your systems on paydays than you do otherwise? No, right? Because your systems have a rhythm. Your systems have a pattern. And you need to understand the rhythms and the patterns of your systems so you can size systems accordingly. Because if you want to move something, you need to have at least that much capacity to that something that you're moving it to. Otherwise, you're just going to run into issues. And then you're going to ask yourself, oh, why doesn't it work the same way? Haven't we all gone through that? Doing the homework and paying attention to these things is fundamental, and especially when going to the cloud. Size your systems. It's the best advice that I can give you. If you don't know what you're doing, hire somebody that can do this for you, right? I'm sure every single cloud provider will throw resources at you to get your workload in there, because that's what they want. They want you to migrate fast to the cloud. They have consultants at the ready to help you with this stuff. And if you don't trust their consultants, you can go hire your own. And there's plenty of really good consultants out there that do this kind of thing. I think that's all I wanted to say about the cloud. So what about big data clusters? And I understand that this slide is small and you can't really read all of that. But I want to stress a few things when it comes to big data clusters. There is mainly two ways to think about the storage needed for, or three ways really, to think about the storage required for a big data cluster. I am going to assume that we're going to talk about big data clusters on-prem, okay? We'll briefly discuss big data clusters in the cloud because it's got the cloud considerations on top of, but bear with me for a second. On a traditional on-prem scenario where you're deploying a big data cluster, there's going to be three types of storage that you're going to be looking at. There's the block storage, likely block storage that you're going to be using for your master instance and for all the other SQL Server containers that don't run Spark big data stuff. And let me kind of qualify that. Here I'm talking about MDFs and LDFs and NDFs for SQL Server. Those are likely going to go into block storage. And that block storage can be anything that speaks block, meaning that can be presented as a volume to Windows or Linux In this case, it's Linux, right? Big data clusters only runs on Linux. And then all Linux-based Kubernetes clusters, because they're Linux-based containers right now. Anyway, you want to present that block storage to those Kubernetes nodes, and that block storage is going to be used then to place your database files and your transaction log files. You want two things in there. You want the low latency of access to your transaction logs, and you want the high throughput that you're going to need for your checkpoints operations and your backups and all these things, and your index scans and all these things that are important for a big data cluster, right? Think about the patterns on a data warehouse. A big data cluster just explodes those patterns into more discrete buckets of workloads, because that's just how they work. They're really just scaling out a bunch of DW-like operations, right? Naturally, there are going to be some portions of the big data cluster that are going to be very transactional. And this is what you really need to start thinking. Is my workload pattern for this portion of the big data cluster that I'm looking at in this particular pool of the big data cluster, is it more of a transactional workload, or is it more of an analytics workload / data warehouse workload? Am I going to be performing a lot of updates, inserts, and things like that, and deletes? Or am I going to be scanning more indexes? Am I going to be doing more seeks against indexes than I'm going to be doing scans? Those patterns matter when deciding what kind of storage I want to pick for my pool in the big data cluster. And that's fundamentally important because it's difficult to implement something that works for everything, right? Especially if you're rolling things in the cloud. You cannot expect the same performance characteristics for a Spark workload on a premium SSD than you would of a SQL Server database running on a premium SSD. They're going to behave differently, right? Because they are naturally different workloads. And so that's what you have to keep in mind. I talked about Azure, but you can extrapolate about on-prem, right? If you have a portion of your BDC, you definitely want to, that it's transactional, you definitely want to use block storage for that. You may want to use NFS whenever possible for big throughput things, like data warehouse-like workloads may work better on NFS, or your block solution may be just as good. Maybe you're okay with some of the Kubernetes nodes for your big data clusters using PCIe attached storage. Maybe you want to put some persistent memory into your master instance, right? And use that for a given portion of your big data warehouse, or your big data cluster, because maybe your workload will benefit from that. But the amount of combinations possible for this is exponential. Okay, what storage should I use for this? It depends. It really does. There is no one answer to the question, what should I be using for my big data cluster? Because it's difficult. But I do want to highlight one thing. Remember the object storage that I mentioned? Those are typically fantastic offerings for this bottom row down here, right? For the big data, on the big data cluster, where you have your Spark workloads, where big data meets the actual transactional portion, not the transactional, the actual RDBMS portion of big data clusters meets the big data portion of big data clusters. For the big data HDFS tiering feature of big data clusters, typically object storage will be very good solutions because they can give you tons of throughput, and they can also replicate data to the cloud, so that if you do need data replicated, whichever subset of that data replicated, you can do that through those means. And you don't have to have a machine or several machines dedicating to reading data off of one device and sending it off to the cloud, where you're going to receive it by some other device as well, right? So that is largely the conversation that needs to happen around big data clusters. How is my given pool, what kind of storage should I be using for it? And again, it depends, right? You may not benefit from throwing PMEM at any of the pools in your big data cluster, or maybe you won't get any benefit from throwing PMEM at your master instance. Maybe you will. It depends on the actual requirements of the workload. And a lot of you guys are just barely starting to implement big data clusters right now, so you don't really know what to expect. The best advice that I can give you in that sense is do educated guesses, because you can sit down and try to figure out what your IO patterns are going to be like for a given piece of your infrastructure. And that's how you end up deciding which offering you're going to pick from the huge many of options that are available to you. And so one thing that I wanted to mention though, because big data clusters runs on top of Kubernetes, you definitely want to look at orchestration layers for storage even, because Kubernetes orchestrates one thing well, compute, but it doesn't really orchestrate the storage underneath the hood that well, meaning it doesn't know how to handle a situation where you have multiple storage devices and doesn't understand what capacity is left in them, blah, 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 blah. All of that is being developed in the Kubernetes ecosystem right now. But the storage vendors are providing these CSI drivers, so container storage interface drivers, that would allow your Kubernetes clusters to understand what's available to them, where to place a given container, or where to provision the persistent volumes that are required for those containers. I would highly recommend that you do that, as opposed to doing things manually in Kubernetes for your big data cluster. In a given enterprise, that's going to save you tons and tons and tons of time, because you don't want to play musical chairs with storage when it comes to Kubernetes. You want something else to handle those decisions for you. And my employer, Pure Storage, has one that works on-prem, and another one that works across on-prem and cloud. So ours is called Pure Service Orchestrator for Kubernetes on-prem. And for Kubernetes in the cloud, we have Portworx. And Portworx also works on-prem. There are the other vendors have tons of different offerings. The list is long. You should know that, of different open source projects and vendor-specific offerings for Kubernetes today. So I mentioned the ones that my employer makes, but I highly encourage you to go look at what's available for your specific vendors out there. Because I know Dell EMC has a ton of Kubernetes stuff, and NetApp also has a bunch of Kubernetes stuff, and HPE also has a bunch of Kubernetes stuff. So you want to talk to your vendors, to your hardware vendors, about how to do this. If you're doing things in the cloud, you kind of want to look for something that is vendor agnostic, right? Where you can just handle whatever it is and actually abstract the fact that you're running on a given cloud too, because that's kind of nice. Imagine being able to just swing things from one cloud to the other without even considering, this is just, there is a particular piece of infrastructure that this cloud that I use in this cloud that I cannot use on the other. You don't want to really be in that scenario unless you're absolutely married to that cloud. Because I can definitely foresee a future where you have something running on cloud A, and all of a sudden cloud B lower their prices, and you want to just swing everything along to the other cloud. Why not? That's the premise of multi-cloud, right? But you also have to play along with that and not marry yourself to any one particular cloud vendor when it comes to storage. Because I think that's the best way of keeping your workloads portable, so that if you do decide to run some workload on-prem, because it runs better on-prem than it runs in the cloud for whatever reason, cost is one of them, performance is one of them, agility, privacy, security, like tons of different reasons why you will want to do that. Don't marry yourself to a specific storage layout, storage infrastructure to the cloud, specifically for big data clusters. And then when Azure Arc comes, which is, can smell it, it's in the oven right now. That also is going to have its own challenges. Like, how do you deploy Arc on-prem? Do you even want to use Arc in the cloud? How do you sync stuff from Arc to the cloud? From on-prem to the cloud and vice versa. The premise of data portability and data mobility matters a heck of a lot when you start thinking about how you architect your solutions for your particular enterprise. So you see how this is much more than just a storage conversation. It's really a data architecture conversation. And that's what I like discussing these topics in the community out there, because not everyone understands that these things are possible. And that storage is actually kind of like the pivot through which that helps workload mobility out there. You don't necessarily have to marry yourself with any given piece of infrastructure, because the cloud may be great, but there may be a possibility for you to run something faster, better, cheaper, easier on-prem, and vice versa. Maybe you have something on-prem, makes a heck of a lot of sense to run it in the cloud. By all means, right? You go do what's best for your enterprise. Makes perfect sense. But in that sense, try to abstract your workload from whatever is running on top of. Because otherwise you end up in the same exact lock-in model that databases have today, which we're moving a SQL Server database out of it and putting it into Oracle. It's extremely difficult. You don't want to do that for your workloads in general, right? Because unless you're absolutely married with that particular cloud vendor and you say, oh, I want to use Oracle Cloud all the time, I don't want to use anything else. Okay. If you want to use Azure and you want to just do absolutely everything with Azure, okay. Right, that's up to you. I personally like keeping my options open. And so if I were to architect something in the cloud for anyone, the last thing that I would consider is something that ties me to that cloud permanently and it will make it very difficult to get out of. Argenis just threw a bunch of opinion in his own session. Sorry, I tend to do that. Beer, do we have any questions pending? Because I'm about to wrap it up.
Certainly do so. We've got a couple of questions coming in. First thing I need to inform you is that Sir Glenn Berry has also been in the session and has been providing amazing answers to people as well.
Thank you, Glenn. I haven't been watching the Q&A, but thank you in advance. You're awesome. Thank you, dude.
So we've got some questions here. Daily, weekly smart scans recommended, question mark.
Daily, weekly scans recommended for what specifically?
I presume they're talking the smart, the old SMART disk scans.
Okay. Smart scans. If you're Backblaze and you have a bunch of hard drives, you're probably scanning your smart counters. You're sweating when you're looking at your smart counters, right? Because Backblaze just backs up your data into all hard drives. You probably shouldn't be as paranoid if you're running Optane drives or if you're running flash SSDs. If you're running an all-flash array, for example, or an object store, those have intelligent flash management or intelligent Optane management. So if those devices are about to fail, they know it in advance, they're warning you in advance, and they have HA built in. But if you use PMEM and you use PCA and NVMe attached, I think you want to have something that checks every so often and sends you an alert if something is smelling awful or starting to even, not smell well. Is that a good answer? I mean, that is the same question as, like, how often should you run DBCC check DB? I don't know. How paranoid are you? It kind of goes along the same lines, right? You have to really think about what gives you the best level of comfort. I will probably throw something daily, or maybe weekly, as because you're just starting with that infrastructure. And then as years go by, because it's literally years before you actually burn one of these devices, unless you just overwrite it and overwrite it and overwrite it and overwrite it, which on PMEM isn't really difficult to do, but we don't have enough data about those devices not being as good as advertised. Thus far, they seem to be. And I'm sure Glenn has tons of opinions and more color on that topic, but I'm presenting today, not him, sorry.
So I've got two cloud questions, but firstly, the most important question of all, please, can you make sure that your slides with all of these details on are available?
Yes, absolutely, I will. I provided these slides to pass, and the recording is available. If there's something missing that you absolutely think should be there for whatever reason, please reach out. I'm on Twitter @dbargenis, or just shoot me an email, argenis@purestorage.com, and I'm happy to help you out.
I think Pass have got the original slides with just the headings on, haven't got the...
That is correct. The original slides that didn't have much in them were the ones that were uploaded earlier on. I provided Pass with an updated version of the slides. That should be replaced shortly. So if you're looking for the updated version of the slides, you will get that soon. I just sent that to them a few minutes ago. Not a few minutes ago, but at this point, it's been a couple hours. But give them some time to catch up and upload the slides, all right?
Excellent. So we've got two cloud questions from Heidi Hastings on the other side of the world from both of us. And she says, she says, is for companies that don't want to be tied into one cloud, can you do multi-cloud solutions when it comes to storage?
Boy, I mentioned one, but I'm biased. It's called Portworx. It's by Pure Storage. We acquired that company recently. I'm sure other storage vendors have their own solutions that they can advertise for multi-cloud. Portworx literally has that model where you're not really attaching yourself to any one cloud. And we have already literally thousands of customers using that stuff. So it's a big deal. You may want to look into that. And I'm sorry for the blog, for the Pure specific blog. I'm just not familiar with the other offerings from the vendors. If there's a vendor on the line that wants to chime in, please, by all means, go ahead. You should be mentioning your products as well. I kind of hate to be product specific and mention the thing and tout my own horn here, but I don't know of anything else. I know Portworx does that. I don't know who else does it. I'm sure somebody else does it.
And the last one, I mean, I think we've already covered this. I think you said get consultants in to help you. But with people pushing for virtual, and some of this hardware is all a black box to us ordinary people, are there things that we can look out for in the cloud world options?
So right now, most of the cloud providers are only offering VMs, and there's a reason for that. Spectre and Meltdown kind of vulnerabilities. If you don't run on top of a VM, you couldn't possibly do multi-tenancy. And so the only way that you couldn't run on top of VMs is by running dedicated hardware. And not every cloud has dedicated hardware. There are new bare metal providers that offer you a cloud on bare metal. Those are not, they're sort of nascent technologies. Some have been around for a few years, and it's becoming all the rage. We're seeing a lot of customers embrace those because they really want to run on their own bare metal. They don't want virtualization layers in between their workload and their storage, and they decided to, and they don't want to run their own data centers either. So they want bare metal as a service. We're starting to see an uptick on that. And I'm sure others have as well. It's an option, right? Not all the cloud providers offer bare metal. I believe AWS started offering bare metal. I don't know about Azure. I think Azure had dedicated hardware, but you still had to run your own VMs. I don't know what the status is on GCP or cloud or Oracle, sorry. Just understand that bare metal as a service is a thing that's coming fast, if it's not ready available already. Great question. I think we're run out of time, you guys, so I think we need to wrap it up, don't we?
Wow, we literally had one come in right at the last minute. It says, can you run commands to find out what type of storage you have in the cloud? This is the last question we'll have.
Not easily, no. If you only have access to the VM, but you don't have access to the portal, meaning the configure or the APIs, so how you provision that VM, it's difficult because it's meant to be that way. It's meant to be so that you don't know exactly what's running underneath the hood. So you're abstracted from the details underneath the hood. I don't know if Azure offers an API for this, for example. You may want to go ask Microsoft. They're at the booth right now, I believe. Well, thanks everyone for coming today. We need to wrap it up. Unfortunately, we're over time right now. I wanted to first of all thank Paz for the opportunity for me to speak. And I also wanted to thank Beard for being such an amazing moderator. Thank you for helping me out, buddy. You're amazing. And to Glenn and the others helping out on the Q&A, thank you so much. All the volunteers at PAS and PAS HQ, thank you so much for what you do. And the rest of the speakers and the rest of the community members, thank you. So everyone, have a great weekend.